In this video, we're going to talk about the Claisen condensation. Let's jump right in. So in a Claisen condensation, we start the exact same way as we did in an aldol. We have a base. In this case, we have sodium plus, which means we have O minus ethoxide, which is a good base. So that ethoxide will go to look for a proton it can pull off, an acidic proton. And we remember that carbons that are alpha to a carbonyl, right next door to a carbonyl, have acidic protons on it. So notice for this carbonyl, there's an oxygen on this side, no alpha carbon, but there is an alpha carbon on this side where it can be deprotonated. So this base, ethoxide, pulls off this hydrogen. These electrons stay behind on the carbon, and it makes this. So we have ethyl, oxygen, carbonyl, CH2. Now we have a lone pair of electrons with a negative charge on that carbon. So now we have an aggressive nucleophilic carbon ready to go attack something. So what could it attack? Well, if we have another molecule of this in there, and of course we have gazillions of these in there, so let me redraw another one of these molecules of my reactant. So I have this negative spot on this. Where's the most positive spot on this? Of course, it's the carbon of the carbonyl. So just like in my aldol reaction and my other reactions, I attack that carbonyl. The electrons go up onto the oxygen. And every time I attack a carbonyl and electrons go up to oxygen, I always ask myself, can they come back down? Are these a good leaving group? Well, let's look at this side. We have a carbon group. That's not a good leaving group. But on this side, we have an oxygen from my ester. So the electrons can come back down and kick off this pretty good leaving group. It's an okay leaving group. So now I have ethyl, oxygen, carbonyl, CH2, and it's bonded to a C double bond O because I reformed my carbonyl. The ethoxide fell off, it's not on there anymore, so the carbonyl just has this CH3 on it. And ethoxide is my leaving group. And that's the final product of a Claisen condensation. There's one more thing I want to show you when you have a Claisen condensation product. I can take the alcohol I started with and make a little card with the hydrogen on one side and the OET, the ethoxy group on the other side. And I can come back here and I can look at the bond I just formed between CH2 and my carbonyl, and I can cover that up, put my hydrogen back in, and I see that I have my starting material. Or I could cover up the other side of that bond and see I have methyl carbonyl OET, my starting material. So you can double check that you've made the right product by looking at that bond, covering up both sides, making it OET, or making it a hydrogen, and you can see that you've got your starting material. That's one way to double check whether you have the final product correct. Let me show you one more thing you should look at when it comes to the base that is used. Notice in this case, the base is ethoxide. And the reason they chose ethoxide is because there's an OET on my ester. And here's why they did that. If this ethoxide, instead of pulling off one of these protons, attacked this carbonyl instead, and the electrons went up, came down, and kicked off the ethoxide, it would make this OET is stuck on the carbonyl, and I would make the same molecule again. No harm, no foul. But if instead of this base, sodium ethoxide, they use sodium methoxide, now the negative methoxide would attack. Electrons go up and come down, and it changes the starting material to this ester with the OMe on it, the O-methyl. And that would lead to an entirely different product. So in the Claisen condensation, we pick a base that matches the ester so we don't get into trouble. Hey, I hope that was helpful. Subscribe to the channel so I can continue to help you with organic chemistry.